in the workbook. Okay, here we go. So if we're looking at number 3, first off, it might be helpful to just get your paper kind of ready for this. So I'm going to put a line down this. Because remember, we're comparing these two functions. We have to compare them. Okay, no problem, Emily. She'll be back. We need to compare each of these. I know that there's an E there. I stopped to let someone in. All right, we need to compare each of these. And the main things we're going to compare are our Y-intercept and our rate of change, which is our M. So here's our two things we need to compare, right? So if I'm looking at the rate of change, which is our slope, and I'm looking at the Y-intercept, which also we know that the Y-intercept is going to be our initial amount. Why is that? Well, let's see. If we're at 2, 1, 0 for x, we're on the y-axis. The y-intercept is going to be here. If the graph goes like that, that'd be my y-intercept. Now, this is always time, so think about it. When time is 0, you're at your initial amount because time's 0. When time's 0, it's like you haven't done anything yet. You haven't lost your money, you haven't earned any money. So if I'm looking at this, we're going to do the problems right below this. I want to look at function A and see what information I can pull out from there. Okay? Now, remember that our x values are talking about time. This is time. As is this x value. X is time. Okay? So since the x value is time, we want to think about this for a sec. We want to think really hard. Because if I'm looking at function A here, what happens if I plug in 0 for x? If I plug in 0 right here, if I plug in 0, the exponent becomes 0. Anything raised to the 0 power is equal to what? Anything raised to the 0 power is 1. 1. Eins. It's 1. So 0, if we plug in 0 for x, which gives us our y-intercept, I plug in 0 for x, this exponent becomes 0. This entire growth decay factor in here, the multiplier, is going to be equal to the multiplier raised to the 0. So all this right here is going to be 1. So right off the bat, I figured out that my y-intercept for A versus B, my y-intercept is 400. So since the y-intercept is 400, we have part of the information done. Okay. Now all we had to do next is figure out what is the rate of change. And we're going to have to do that on the right side as well. Now here is the thing. We're doing it on the interval of 2, 8. 2, 8. 2, 8. That's the lower and the upper. Okay. So the lower and the upper is talking about, okay, where is our window going to be? Where is our window going to be looking at? We are looking at time. So what we're doing right now is saying we're only going to be looking between 2 and 8 as far as our time goes, between 2 and 8. Okay. So if that is the case, then I need to go in. This wasn't for this problem. I need to go in and figure out, okay, well, what is some information I know between 2 and 8? Up here, I know we're looking between the time of 2 and 8. So I've actually I already have my points for function B. I already know that we're looking between 2, 398.45, and I'm looking between 8, 587.88. Remember that the interval just says what x value, the x lower and the x upper. Okay, lower and upper we're looking at. So now we have the interval in mind. let's go ahead and we found the y-intercept for A. Now, what's nice about this is for B, the y-intercept. I'm going to highlight these as I go because I'm not organizing it as well right now. A had a y-intercept of 400. B is going to have a y-intercept. Now think about it. Think about it like I said up here, this one I scratched out. When x is 2, time is 2, time is 1, time is 0, you're on the y-axis. When time is 0, that is your y-intercept. So I look up here and I see that, well, function B has an x value of 0, the y value is 350. So what I know is my y-intercept is 350. Because we have this point, 0, 350. So that tells me it's a y-intercept because 0 for x is on the y-axis. All right, so we have our two y-intercepts. I can already see that function A starts with a higher value. It starts at 400. So now we just have to look at the slope. Now, let me think of the easiest way to do this. B is easier to find the slope. So I want to do it for B first. And what I know is I'm looking at the slope between 2. So I'm looking for the slope. It's between 2, 398.45 and 8, 587.88. Okay. So because I have those 2 points, those are the 2 points that are in my lower and upper boundary for my interval. So the interval just tells you what x values to look at. So since it's between 2 and 8, what I did was I went to the table and I said, well, 2, 398.45 is a point. 8, 587.88 is a point. So those are the 2 points I'm going to find my slope in between those 2 points. Watch. Let's say that this is x1, y1. It doesn't matter which is the x and the y, or the 1 and 2 group, just be consistent. All right. So all I need to do here is plug in y2 minus y1, x2 minus x1. So this lesson has a lot of components that we've seen throughout the year. We've worked on finding like the slope of this before. Okay. This is just asking you to do multiple things, so don't let that trick you. Don't let that trick you. All right, here we go. M is equal to 587.88 minus 398.45 over 8 minus 2. That's calculator work, guys. Let's do the calculator work. 587.88 minus 398.45. And that's 189.43. 8 minus 2 is 6. So we're going to get our slope right now. Wrong class. Somebody just tried to get into this class. They're not even in this class. Divided by 6. And we get 31.57. All right, there's my other piece of information. Now remember, all we're doing is comparing the y-intercepts and the slope. So once I find the slope of the other line, the other function, we are done. Okay? So this is where it gets a little bit tricky because I have this function. I'm going to simplify it because this function is still pretty wide open. So we need to do the 0.06 divided by 12, and then we're going to add 1 to that. So essentially we got y is equal to 400, 1.005, 12 to the x. Okay. All I did was take the 0.06, I divided it by 12, and then I combined it with positive 1, and that's what I got. Okay. So let's see what time we're doing here. Okay, perfect. So look, here's the thing. Remember, we want to find what the slope is between 2 and 8. If I was just drawing a graph here to kind of visualize this, 1, 2, 3, 4, 5, 6, 7, 8. We're looking between 2 and 8. We're seeing what is happening to this function between 2 and 8. Now this function probably is looking something like this. So you don't have to graph it. You don't have to know the exact points or the exact shape, because what we know is we just need to know, just like I found my points over here by looking at the table, right? I looked at the table 2, 398, 8, 587. Over here, all we need to do is plug in 2, plug in 8. That's going to give us our y value. And then we just go in and do this process. It's a little bit more cumbersome here. But look, this is just calculator work. So let's do a little bit of calculator work. We're going to plug in 2 for x. Okay. Now, right off the bat, I know that 2 times 12 is 24. So essentially for this one, I'm going to go 1.005 raised to the 24th. And then I'm going to take that and multiply it by 400 times 400. And I get 450.8. Okay, so now we got to do it for 8. Let's see, 12 times 8 is 96. So let's do 1.005 raised to the 96th. And then that's all of this. Now let's multiply it by 400 times 400. All right, 645.7. Let's do that. Okay, now just like over here, how we had 2 points, now we have our 2 points. So now we could plug it into our formula, get our final slope, and compare them. So we're going to do y sub 2. Since these are the points 2, 450.8, 8, 645.7. We're going to just label these 1 and 2 group and then finish it up. Nelson, you're in here? Yeah, you are. What are you doing now? Okay. So let's go. Let's see. Y sub 2, 645.7 minus y sub 1, 450.8 over x sub 2, 8 minus x sub 1, 2. So here we're going to just go ahead and knock this out. Minus 450.8. And 8 minus 2 is 6, so we're dividing by 6. And we get 32.5. Oh, one sec. I'm sorry. I labeled this y. It's not right. It's m. That's our slope we just found, not our y-intercept. So let's see what we got. We have function A, y-intercept of 400, initial amount is more than function B. Function A has a slope of 32.5. Function B has a slope of 31.57. So this is what I would say for all this. I'd say function A has a greater starting amount, or y-intercept, and increases faster. How did I know this? Function A has a greater y-intercept, which means it has a greater starting amount. It's 400 versus 350. Function A has a greater slope than function B, so I know that function A is increasing faster. It's increasing faster. Okay, so that's all we have to do. We have to find our 2 y-intercepts, compare them. Find your slopes. The higher the slope, the faster it is increasing. All right. Guys, give me a thumbs up, sideways, down. How do you feel about it? I'm guessing sideways. Yeah. Yep. Okay. We don't have homework tonight, so we are going to look at this again tomorrow. I don't know that we have a time to go through one additional problem. But for this week, because last week was a little bit odd, this week we will have an extension with homework. It won't be late work. I'll give you the entire week to do it. I won't be counting it late work. Let me pause. Okay. That took 15 minutes to look over that problem. Now we're going to look at number 4. It's going to be faster though, guys, because number 4, we could see things pretty quick. Remember, we just want to know what the y-intercept is and what the slope is, right? That's what we're looking for A and for B. Now, here's the thing. We're looking between the intervals of 0, 5. So the y-intercept is whenever x is equal to 0. So if I plug in 0 here, 2 to the 0 is 1. 2 to the 0 is 1. So when I plug in 0 for x, for function A, my y-intercept is going to be equal to 3. Because you plug in 0 for x, 2 to the 0 is 1. 3 times 1, 3. Okay? Let's look at B. Because B is going to be nice because it is the y-intercept. You can see it on the graph. The y-intercept is at 0, 0. All right. Y-intercept, 0. You see, so when you have a graph, or actually when you have a graph or a function, it's easy to plug in 0. So when you plug in 0, you're just going to get your y-intercept. Okay, because look, when x is 8, 7, 6, 5, 4, 3, 2, 1, 0, x is 0, time is 0. You haven't started yet. You're starting and you're seeing what your initial amount is when x is 0. So we look up and down, it's at 0. It's not up here at 400 to start. It's at 0 to start. That's why I put a 0. Now, the slope is going to be between 0 and 5. So I know on the graph, I'm going to look between here. And I look that this is my point at 5. This is my point at 0. So this is what we're finding when we have a graph. We're finding the slope between those 2 points. Because this slope will actually accommodate all of the little slopes, the changes that are happening here, all these tangent lines. This is the average slope between these 2 points. Okay. So what I'm going to do is I'm going to go ahead and look at B here. And I'm going to say, okay, well, I have some points. My points are 0, 0. And then this is at 5, 500. I'm going to say 5, 500. Right, this point right here, 5 for x, about 500 for y. So that gets me here 0, 0. That's the left side. Since the interval was 0, 5, we go over to 5, and it's at 500, 400, 600. It's in the middle. So now I have my 2 points. Let's go ahead and plug them in. We're going to go with this equation for both of them. y2, y1. x2, x1 minus x1. They're both minus. Okay, so let's go ahead and plug them in. x1, y1, x2, y2. All right, so my slope here is going to be y sub 2, 500, minus y sub 1. Y sub 1 is 0. I love it. I know where this is going already. X sub 2, 5. X sub 1, 0. So we get 500 over 5. We get a slope of 100. Okay. So my pieces of information again. Y-intercept, done. Slope, done. For A, we had the y-intercept. And now we have to find for A, we got to find what the slope is. Shoo! Getting there. All right. So what I want to do is I want to plug in x and y. I'm going to plug in 0 and 5 for x, because those are the boundaries I'm looking for this function. You plug in 0 for x, 2 to the 0 is 1 times 3, we get 3. You plug in 5, now I got to do it on my calculator. I plug in 5 right here, 2 to the 5th power. 2 to the 5th power is 32 times 3, 96. All right. So now, all we have to do to wrap this up in the last minute here is look at these points Label your 1 and your 2 group. Use our function that we have here. Our function that we have here to find the slope. Let's go ahead and do it. So we're going to have slope is y sub 2, 96. Minus y sub 1, 3. X sub 2, 5. Minus x sub 1, 0. So we're going to get 93 over 5. And we get 18.6. All right. Yeah. Woof. We've done all the work. Now we just got to say what we see here. Here's my slope. All right. Last thing before we close up. Let's see. A starts with a greater amount. It starts with a greater initial amount than B. B increases much faster than A because it's 100 versus 18.6. So that would be my answer. I'll just abridge it here for us. Let's see. Function A starts with greater amount. But function B increases faster. Okay. This is number 4 in 2.6.1. That would be my answer. Remember, you got to state it and compare them. Okay. All right, guys, we're 1 minute over. We will look over this at our next class meeting, and it will be delayed on its due date a little bit. Okay. All right. Any last questions? You guys good? All right. Well, it was good to see you guys. I always like seeing my second period. Have a good day. I will see you next time. All right. All right, I'm recording again. All right, so we're looking at this problem here. We have, let me get so I can see your guys' faces. Where'd you guys go? Where did you go? There you are. All right, so you guys, we did the linear equations. How did we feel about the linear equations? Looking for the y-intercept, looking for the slope. How do we feel about linear lines? Pretty good? All right. I think when we go over this will reaffirm things we learned in the other section as well. The only difference is that now we have an interval to deal with. With the linears, there wasn't really an interval because we have a slope that's consistent. It's a line. Here, the slope varies. So here you see with an exponential, the slope is very steep, and it gets less steep as you get down through this exponential. So it's important with an exponential to have an interval that you're looking at. In this case, the interval is between 0 and 10. 0 and 10. We're looking to see what is going on between 0 and 10. So I like to extend my lines up and write in the book. It's always fun to write in books. What? So at 10, I'm at that point. At 0, I'm at this point. So remember, we were just looking for the interval. We're looking what's going on between those intervals. Okay. Now, there's going to be 2 pieces of information we're going to end up with. We're going to end up with the y-intercept, which if you think of where the y-intercept is, since this is time, this is days in this case. Time, when we have the y-intercept, time is 30, 25, 20, 10, 5, 0. When time is 0, it's your initial amount. It's where you start. When time is 0, that's how much you start with. Okay. So the y-intercept is our initial amount. Initial amount. Okay. So we're going to find the y-intercept. We're going to find our rate of change, which is our slope, our m. And we're going to do the same over here. We're going to do that over here too. So we're going to have our y-intercept, and we're going to have our slope. Okay? So we're going to just put those pieces of information out there once we figure them out. Once we figure them out, then we can compare them. So an example of comparing would be function A starts with a larger initial amount, right, from the y-intercept. And maybe in this case, function B has a greater rate of change. It's increasing faster or decreasing faster. So Looks like we're losing. We're losing, and this is going downhill. So it's how much is being lost with both of them. Okay, so let's see. A fully inflated beach ball is losing 7.5% of its air every day. The beach ball originally contained 800 cubic inches. So original is talking about the initial amount, the starting point. So for A, the initial amount, originally containing 800 cubic inches. That was pretty quick information to pull out. That was pretty quick. Now over here, the y-intercept is right here. Oh man, it's 800 as well. 800 inches cubed. Inches cubed is my units. So look, these are exactly the same. So in this situation, we're going to be saying that both functions start with the same amount. The y-intercept is the starting amount. Now, let's find the slope. Over here, essentially, we're looking between these 2 points. We're seeing what this slope is along this segment, this interval from 0 to 10. So I know that my 2 points up here, are 0, 800. 0 for x, left to right. 800 for y, up and down. 0, 800. I also have the point 10 for x. Okay, that's going to be 450, 500. I'm going to go 490. Yeah, let's do that. Okay. So when you're looking at a graph, to find the slope, you look at the point that is located on the interval edge. The lower edge is 0, so I'm looking at this point because it's right on 0. The upper edge is 10, so I'm looking at this point because that's where the graph hits at 10, right? At 10. So now all we have to do here is identify which is our 1 group, which is our 2 group. Because if I said, hey, what's the y value? Someone might say 800, someone might say 490, because those are both y values, but there's a 1 group and a 2 group. The reason being is we're going to put it into this equation. For both of them, we're going to look at the slope as y sub 2 minus y sub 1, x sub 2 minus x sub 1. All right. So let's go ahead and put that in there for these points for function b. This is for function b. Let's see, y sub 2, 490, minus y sub 1, 800. It doesn't matter. I will go back a second here. It doesn't matter which is the 1 in the 2 group. This could be the 1 group. That could be the 2 group. Just keep them consistent. It won't matter because we're finding the difference of the top and bottom here. X sub 2, 10, minus x sub 1, 0. So what is that going to be? Negative 490 minus 800. Yeah. Negative 310 over 10. M equals, what is that, 31? Negative. Okay. So my 2 pieces of information for B is my y-intercept is 800. This is B. My y-intercept is 800. My slope is negative 31. All right, give it to me. Let me know. Thumbs up, sideways, down. How do we feel about the graph part? With the graph, I know it's a couple steps, but you know the parts. I promise. Marco, you have a question?
Yeah, so I calculated as 475.
You did it? Okay. You know what? I would absolutely take that because here's 450. Well, actually, I'll say this. 450 is here. 500 is here. So I would actually say 475 would be more directly in the middle. But that's approximately correct, and these units are hard to see that. So I would take 475. I think it is a little closer to 500 than 475, but that is not a perfect graph to read. So It's okay if you calculate it that way. Do you see why my argument is something? Okay, so next time look really close. Always divide that segment in half. 475 would be in the middle. And then from there you can decide above or below. Okay. No worries, no problem. Let's do A now. A. So this is number 5 in 2.6.1. All right, let me make sure I got time. How are we doing? Perfect. All right, so let's look. A fully inflated beach ball is losing 7, so we're going down 7.5%, which I know is 0.075. Every day, the beach ball originally contained 800 cubic inches. This is going to be a quick one because we have A times 1 minus, because it's losing, 0.075. Because it's every day, it's going to be X. It's one time every day. One every day. So you look at the unit of 1. Have you gotten the full growth after 1 day? Yes, it says every day. I could have put 800 in here. I don't know why I didn't. 0.925 to the X. Okay. Now, the only other thing we have to do here is, over here in the graph, we were able to see what the values are at 0 to 10. Here, we can't necessarily see that for A. So what we need to do is plug in 0 and 10 for X, get your point, and then plug it back into our slope formula. Okay. So I know there's a lot of steps to this, but just keep on remembering, what am I doing? I'm just trying to find the y-intercepts and the slope. Okay. I don't think those two issues, if they were alone and there weren't like 6 steps to all this, each step you can do. So just remembering which steps we're going to start with. Here we had to create our equation. We have to look at 0 and 10. And when I do that, anything to the 0 is 1. So when X is 0, Y is 800. That was easy. Okay. Anything to the 0 is 1. 1 times 800 is 800. Now let's do it for 10, and we'll call it 0.925 to the 10th raised to the 10th times 800. Y is 366.8. I'm just going to, whatever. 366.8. All right. So now we go to find our slope. We're using this equation up here. We need to first go in and label it. Let's call this x1, y1, x2, y2. Y2, 366.8 minus y1, 800. X2 on the bottom, 10, minus 0. So we get, let's see, minus 800. We get negative 433.1 over 10. We get a slope of negative 43.31. Whew! I'm tired. All right, we got it. Let's see. Where can we bring all this together now? Let's see. Down here as well, we had the y-intercept. We knew it was 800. Oops. So look, now I just have to explain what the heck just happened. Look at our slopes. Function A is decreasing faster. It's a larger negative. It's negative 43 versus negative 31. It's decreasing faster. Function A and function B start with the same initial amount. So I would say, for my answer, function A and B start with same amount. And then I'd say function A decreases faster. That's what I put. All right. Yeah, this one's tricky. This one's a little tricky, and they also give you a bunch of different types of graphs versus find the equation versus tables. So we just got to remember that's all the same information, just kind of presented to us differently. All right, for number 5, if anybody needs a screenshot, go ahead and screenshot it, please. All right, screenshot. Yeah, Marco, you're good. So we're good with 3. If you need to double check, I'll post it later just in case. All right, take care. All right, guys. Well, we only have 6 minutes, so I could try to do another problem quickly. If you wanted to just, you forgot to do homework, you want to get some down. So let me know in the chat. Is there any others I should do? We did 5, and I will pause it. Yeah, no problem, Calvin. I'll go and pause this for a sec here. All right. All right, Ava. All right, guys. No problem. Anybody else want to see another problem? Or you